Welcome back to session 14. What we're going to look at in this is we're going to look at just a small piece of the maths that we do, which is called literal equations or changing the subject of the formula. Let's just have a look at it. Literal equations. The other thing is it's called changing the subject of a formula. Okay? The other thing is they could say express in terms of something, right? Those are the hidden sort of elements that we need to do, all right? Where does this come from? Well, it comes from if you're in financial maths or if you're in physics or chemistry. Very often there's a formula, and let's take an example. Let's take this one. For those of you doing A levels, you'll recognize this. S equals ut plus a half at squared, well, O levels, right? Newton's laws of motion, okay? You'll see it later in the year in physics, where we look at things, how they move. It's not expressed like that locally. That's generally speaking the one that you're going to see in university textbooks, etc. Okay. Right. Now, let us, for example, say that's the given. And let's say we want A. In other words, we want A equals what? Okay. That's what this is all about. It's to change it so that A is now in the front. Okay. Well, what do we do? Okay. First of all, it could be make A the subject of the formula. That's the first thing they could ask. Make A the subject of the formula. B, they could say express in terms of A. So it could be make A the subject of the formula. Okay. Or express in terms of A. They mean the same thing. Okay. Well, what do we do? Well, the first thing I do is I say, right, A is on the right-hand side. I'm used to looking for it. I want it on the left. So I flip the whole thing around. And I say that ut plus a half at squared is equal to s. Same formula. I've just swung it around the equal sign. Why? What's my logic? I want A on this side. Now, the secret here is to pretend that everything else except A is a known number, right? So we look at it in terms of A is the unknown, okay? A over there. So A is the unknown. Like an X, what do? We take all numbers, so we say, hang on, if it's an equation, all A to the left-hand side, all numbers to the right-hand side, correct? Okay? A to the left, all numbers to the right. That's what we do. So now we say, okay, fair, but then hang on. This is some number. It's a known number. It's not an unknown, which means I just subtract it from the other side, correct? So I then say a half at squared is going to be equal to s minus ut. Can you see that? We just take it to the other side. The next one, I don't want a half. This is the next. Can you see? This is like an onion. We're peeling the layers away. There's the first one, gone. Now we've got to get rid of this one here. How do I get rid of a half? Divide through by a half or times both sides by 2. Here's where you've got to be careful with brackets. Okay? Rather put them in, don't leave them out, because just to put a 2 there means 2 times s, but it's actually got to be times both. So that leaves us with at squared equal to 2 times s minus ut. Correct? Right, now I only want A. So it's a times, what is t squared? T squared is a number. It could be 5. Okay, we don't know. But it's a number, so we divide by t squared. And therefore a is 2 times s minus ut over t squared. Okay? That's the first one. All right. And you'll see that these are pretty straightforward. Okay? Now, all right. Okay. Let's have a look at this. Express in terms of a. Okay. So here they've said express in terms of a. Okay. And they've given us a formula. T is equal to the square root of a squared plus 2b squared over 5xy. What do they want? They want a in front, don't they? Okay. So how do I get a in front? Okay. Well, first of all, I tend to switch it around, as I said. So I first of all say, therefore, square root of a squared plus 2b squared is equal to over 5xy is equal to t. Now, let's start peeling away the onion. What's the first layer? The first layer is a square root, isn't it? The first layer is this one here. Okay. How do we get rid of a square root? If I tell you the square root of x is equal to 16, or let's say 4, therefore, I get rid of that, I square both sides, correct? You do the opposite. So therefore, I square both sides. If it's a cube root, I cube both sides. So what do I say? Therefore, a squared plus 2b squared over 5xy is equal to t squared. Straightforward. What's the next? Next is, I then say, right, now I've got to take, the next is, the number is underneath, isn't it? The 5xy. So we multiply by 5xy over 1. So therefore, a squared plus 2b squared is equal to t squared plus 5xy, right? Oh, sorry, times 5xy. See how easy, I made my own error there, right? Okay, that was my writing. Oops. Like that. Okay. Now, what is next? Next, I only want the a on this side, so I subtract the 2b squared. So that's 5xy t squared minus 2b squared. Lastly, I've got the square root. I've got the square. And if I know that x squared is equal to 25, the opposite is the square root of x squared is the square root of 25. And the square root of x squared is x is equal to plus or minus 5. So a is going to be equal to the square root of okay. So far so good. These are actually quite straightforward. Right, let's say they give you something like this. These are some odd ones that appear occasionally. They say make x the subject. Make x the subject of the formula. And they give us 3x squared minus xy minus 2y squared equals 0. Oh my word. Can you see that that's not a very pleasant thing? Because how am I going to split it apart? The secret here is we factorize. Okay? These are special cases that come up occasionally. All right? So let's factorize. Well, first of all, I factorize this like so. And I say, okay, 3x, that's my only option and an x. And the only other option is a 2y and a y. All right? I've got to go through the whole process, plus, minus, all right? minus plus, Kev. Okay. Okay. It's just, okay. See, minus, oh, come here, you. Minus and a plus. 3x squared minus 2xy plus xy minus 2y squared. There we go. So the final thing is going to be 3x minus 2y equals 0 and x plus y equals 0. Now we go back and we say, what are they? Oh, they wanted x. That's the guy we're after there. So therefore, x is equal to minus y, or 3x is equal to 2y, x is equal to 2y over 3. All right? In essence, we have solved for x as opposed to really making it the subject of the formula, but let's just go with it. Let's look at this. Express in terms of r. It's express in terms of r. Right? E equals capital E over r plus r times big R. All right? Now, once again, this is a trick, okay? Trick as in, basically, what have we got to do? We've got to come up with a way to make R, okay? This is the one they want, but you can see R in there is linked with R down there. There's not an easy way to do this, okay? So I said, all right, therefore, first of all, let's get rid of this denominator by moving it across. So E times r plus r, there are no rules for this, okay? That's why I'm doing these tricks, is equal to E r, right? Now you multiply out the brackets. This is the trick. You get ER plus E little r is equal to E times r, all right? So where are we now? Well, what do we want? Okay, we want r. This is the common guy. We want these together. So put them together. And then let's say it does this, correct? Okay, it's going to do this. It's ER minus ER, okay, plus ER equals 0. Look what I've done. I've brought this across and grouped the like terms, which is the R, because this is the target, but R is the target, isn't it? So I group like terms. So therefore, now I can take out R as common, E minus big E. And let's take this ER to the other side. All right. And that leaves us basically with R is equal to, because I'm going to divide by E minus E. ER over E minus big E. Okay? And it's going to be a minus and a minus, because when I take this over to the side, it becomes a minus sign. Okay? Let's look at another one. All right. V squared equals U squared plus 2AS. Let's say we want S, the subject of the formula, express in terms of S. What do we do? Well, I always take it to the other side. I say U squared plus 2AS equals V squared. In other words, I mirror it about there, okay? Because I'm waiting for S this side. Okay, this one is a number, isn't it? So numbers must go to that side. So therefore, I can then say, right, you're a number. So 2AS is equal to V squared minus U squared. Therefore, divide by 2S, correct? Or, sorry, 2A. Therefore, that cancels, 2A. So S is equal to V squared minus U squared over 2A. All right. Essentially, what we do is, apart from the tricks, right, where you've got the linked ones, all right, and those others, we'll do a few in exam prep, but really, all you're doing is peeling away the levels of an onion, the bit by bit by bit. Remember, the secret is don't get confused, okay, by the fact that you've got, let's say, a whole lot of variables, okay? Let's look at this. V equals 4 over 3 pi r cubed, all right? That's the volume, all right, of something. Let's have a look. Let's say express in terms of r, make r the subject. Step one, but first of all, you can see you've got a whole lot of things, volume, r's, and all sorts. Just pretend everything except your focal variable, the one you're looking at to isolate on its own, R. Everything else is a number, so it must go to the opposite side. All right? Like I said, I turn it round. 4/3 pi r cubed is equal to v. I don't want 4/3. I want to get rid of that. It's a number. So therefore, I multiply by 3/4 so that we can cancel that. And I'm ending up with pi r cubed is equal to 3v/4. Right? The next step, what do? I don't want pi. So we divide through by pi. Okay. Therefore, r cubed is going to be 3v/4 pi. And lastly, I do not want r cubed. So what do? I take the cube root of both sides and I say r is equal to the cube root of 3v/4 pi. All right. I know it looks it is very straightforward. It is very easy. Just, it's just to practice a few. The ones that are the most popular, some are, as I say, in the exam prep or the test prep section that we're going to do as well. But essentially, it just takes a bit of practice to see those two tricks and then remember them. All right? And there's a guaranteed 3 or 4 marks straight away, because there's always going to be one in every single test, mid-year and at the end of the year. And you basically just got to recognize them. Okay? The next section we're going to go on to is simultaneous equations and thereafter inequalities. I hope that was informative. Just remember with these, just keep your head. Don't get confused by you've got M's and Q's and B's and whatever. Just focus on the variable that you're looking to isolate and pretend everything else is a number. Okay? That is the way to do it. I'll see you in the next session. Cheers.